Lucas, welcome to the show. Pleasure to have Lucas from Luke. That's probably, is
Look,
that a coincidence? Lucas from Luke?
no.
Okay. Okay, I think you're the in charge of product, correct?
That's right. I'm the VP of product here at,
Okay.
it is pronounced Look, but I do try
Oh,
to encourage Luke as it is closer to Lucas.
yes.
But
Why not?
yeah, no, I've kind of been here since the beginning. I've known the founder Dom for a long time. And, we used to argue about, I was a big LiDAR guy early in my career, and we used to argue about LiDAR versus entry workflows. He thought you could get really accurate data sets with just the photos. I didn't think so. He won out. He proved me wrong. And so I had to join him in this venture.
Yeah, I want to talk about that a lot more because that technology is fascinating to me, both photogrammetry and LiDAR. But where are you, Lucas, where are you calling from?
I'm calling him
That's
from New Brunswick.
okay. That's a long way from the company headquarters in San Diego, correct? Yeah.
So I did used to live in San Diego for a while, and that's where I met the founder. But I'm from Canada, and I'm back here now.
All right, New Brunswick. That's one of the maritime states, correct?
Correct.
Oh, by the way, so my history of photogrammetry goes way back, and I've always been a champion of it because it looks so good in theory, right? It just looks like it would work all the time. All you need is a camera, and you can make these amazing models. But in practice, it tended to be a little bit more, how should I say, onerous, right? Not as accurate. And then when I saw LiDAR, I was aware of LiDAR too at the same time. I thought, oh, LiDAR's got all the advantages, so accurate. It goes out, sees so far, it sees through things, right? This is like X-ray vision, right? This is what everybody should have this. And how do you see that playing out in your company now? And are you using both technologies, or are you favoring photogrammetry?
Yeah, that's a great question. So I'll give you a quick overview on the product first. First of all, we are a fully camera-based technology. So we have a proprietary hardware solution. And for anyone, watching online, I know this is a podcast, so audio-based, but I'm holding up the hardware here. You can see we have four cameras in the front and then a built-in GNSS antenna, which is a very, important part of the process. We
Right.
often operate in exterior situations. So being able to pull in, corrected GNSS along with the four cameras really is
Hold
what
that up
helps us.
again, Lucas. Hold it up again, because when you light it
There
up,
you go.
it reminds me of Thor's hammer. This is it's, but this is the central product, right, of your company. This is what powers everything. This is your unique selling point, right? It's also I think it looks like it's also part of your theme of the emblem. Am I looking at that correctly? That Luke's logo is actually that. Yes, it is. There it is.
Yep. That's
Uh-huh.
right there on the back.
Okay.
I think what actually sets us apart is the computer vision and photogrammetry on the back end. What people ended up really noticing us for is this hardware, just because it's kind of so different than
Uh,
anything else out there. So it's often when people talk about look, the hardware is the first thing that they think of. But no, you are right. It is the foundation for everything because if you don't have very, reliable and high quality and, the right amount of images, then that's where the photogrammetry starts to fall apart. So you really have to be able to control the capture in a rigorous way. So if you're trying to pull in images from a variety of different sources, you're going to get a variety of different results, right? So it was very important for us to create something that one both brought in the GPS and integrated it with the imagery, but also that we're controlling the quality and the rate of capture, which is required for our stack. So a bit about our product suite. We have the camera, which is the QCam, our kind of cloud-based processing technology, which is QAI. And then we have our web application for interacting with the data, which we call QApp. And the way a normal user would interact with it, is they would power on the camera. It's very easy to use, intuitive. I mean, most people are used to looking and taking pictures of things, right? So as you're capturing, we have some guidelines, but in general, if you can see it, in the imagery, then it's going to reconstruct in 3D, right? So you walk around, you're capturing the imagery, you upload it, it gets processed, and then we make a variety of data sets. So point clouds, panos, we make like a ground-based kind of orthomosaic view similar to what you would get from, drone aerial photogrammetry. We do some, automations on the back end for very specific workflows, kind of specifically surveyors and make ready and pull loading analysis. So those are our key segments right now.
Yeah. Hopefully, no, so it sounds like you've totally swung over to the other side now. You're a champion of photogrammetry and vision systems. Hopefully, you didn't tell too many people to shoot you if you ever you swung over to photogrammetry, right? Being a LiDAR champion initially, right? And you have a degree in I won't say a degree in LiDAR, but a degree in geomatics, correct?
I do.
Yeah.
Yeah, I suppose you could consider me a bit of a LiDAR trader now in a sense, but I have a degree in geomatics engineering, which, we covered a lot of things: land survey, remote sensing, ocean mapping, GIS, land administration. So, a kind of a well-rounded background, but I did spend most of my career in remote sensing, reality capture, aerial mapping, starting with planes and helicopters, then to drones. LiDAR was always a big part of it. Just for
Yeah.
one, like you said, the vegetation penetration is important. And that is one thing that, you can't do with photogrammetry at this stage. So there's always a place for both technologies. I kind of see this as very complementary
Yeah.
in a lot of senses. But one of the main drawbacks to the photogrammetric methods was just that you wouldn't be able to get the level of detail on, say, on hard features, curbs, retaining walls, anything that is often required, for, let's say, like engineering purposes down the line, specifically like civil and infrastructure. Traditionally, if you've worked with, drone photogrammetry, you'd see a lot of kind of rounding and smoothing of edges and features kind of joined together. And that's really, I mean, one of the reasons that I joined, and one of our main selling points is that we're actually able to replicate that, just being, due to the quality of our imagery and the refinement that we've done to our processing stack. So we're getting very sharp features on things like curves, retaining walls, and very thin features like power lines as well, which are very important to our customers. So we've kind of taken photogrammetry as a concept, like you said, you get a lot of detail, you get great colorization, and then we've been able to kind of improve the performance of these photogrammetric techniques for specifically kind of engineering and survey applications.
Mhm. Yes, your camera, is it only handheld, or is there also versions that can be mounted on, say, other platforms, maybe even drones?
Right now, we're very focused on the handheld capture
Mm.
portion of it, because a lot of these projects that our customers are working on require a high level of detail. For example, if you're doing survey, you might have to get under trees and around behind things to be able to see everything. And if you're doing more of like an overhead utility pole based workflow, you have to get around the back of the pole to see the tags. So it does lend itself well to the type of work that our customers are doing. But you can operate it at a very slow speed. So we have some people doing scooter captures and that kind of thing. But we do have plans to move into mobile and more spaces in the future.
Got it. So that device looks amazing. How many lenses and how many images is it getting? And then I want to talk about how it's able to process that and also determine objects from photos. So first things first, how many lenses and what's the technology, hardware technology that's using?
Yeah, so four lenses, four cameras in there that are all capturing simultaneously. We're getting around 2 images per second at the moment. It's kind of an adaptive thing at the moment. I think if you're going kind of at a brisk walking pace, that's what you would get. They're all assembled by hand in our office in San Diego. So it is very different than, let's say, a consumer grade off the shelf camera. It's a, calibrated piece of field equipment. So we are, focusing all the lenses individually. Then we're mounting it to like a robot arm, and we move the camera through, like a fixed kind of trajectory in our calibration room with the checkerboard targets. So every piece of equipment has a custom calibration associated with it that we can then monitor on the back end to sure it's not, drifting away for where it should be, as well as push updates to it. So it's a very rigorously tested and calibrated piece of equipment. And that's honestly what's required. If you want to make high accuracy models, you have to have that kind of thing set in place.
Is that 2 frames per second per lens per camera?
Yes.
Okay. And what's the resolution?
It's like in a joint 20 megapixel camera, so combined from the sensors.
Okay. So you get a ton of images. How are they transmitted to, where are they transmitted to? The cloud, or are they a central processing unit nearby?
So as you capture, the images are encrypted and stored on a device. So there's nothing that really could realistically be taken off of it. And then when
Mhm.
you get back to the office or wherever it is that you're working, somewhere with a fast, reliable internet connection, you upload the data, goes to our cloud environment, and then within generally 12 to 24 hours, the data is available to you. It's all fully processed. You log into our web application, and then you start interacting with it.
Okay. So I'm sort of familiar with the initial attempts at using reality capture for commercial projects, and of course, they stressed that you could use an ordinary digital camera. I think there was one example even of somebody just looking out the window of a airplane and able to get the entire Las Vegas Strip from there, right? So I always question that. What is that it could be done? So you've taken a different approach. You emphasize the hardware. It's commercial camera, unlike anything I've seen. Now, the trick here now is to convert those images into a 3D model. And that's where I always felt like the difficulty comes in, because you have to register all those images, right? You have to create some kind of 3D model from those 2D images. That's a lot of work. Never thought it could be done easily. Just the steps that involved with manually taking a picture, hundreds of pictures around an object, that looked like it was a ton of work, right, for a person. So that's sounds like it's all automated now.
Listen, I've done plenty of projects where we took images or LiDAR or other things and kind of were able to stitch them together
Mm.
through, let's say, great manual effort from very experienced technicians and a lot of, ground control points.
Right.
I think what we're trying to do here is to say, like, listen, let's give you something that is reliable and that performs in a very consistent way and reduces the amount of technical expertise required to get to that 3D model and frees up, your technical experts to spend more time on the analysis or extraction or, whatever it is they do best, as opposed to trying to finagle a bunch of different data sources and get them into the format that you need.
All right. So I don't have to do that registration. It's just done. It recognizes points. I don't have to put any. Is this way old school? I have to put things in the screen that help the registration marks of some kind. I don't, that's
No,
not.
no, it's all done. It's all done automatically. I mean, the one thing that you can do is you can upload field ground control measurements, that a
Uh,
surveyor might get from a total station or like a higher accuracy GPS instrument, for example. But yeah, no, in terms of the data registration, the 3D model generation, there's nothing that you need to do. You walk around, we're capturing data. We have some kind of recommended procedures depending on the type of job that you're doing, and you upload it, and then you go on and there's your data right there. And if you want to supplement with other, like I said, ground control measurements and whatnot, you can do that at a later date.
okay. I see on your site that it claims a very good accuracy. I think you say 1 centimeter accuracy, which is quite something for photogrammetry models. Is that unique? Is that advantage, or are you tops in that field?
So I mean, a couple of different things. So let's say like the absolute accuracy, the georeferencing, where is this thing globally in the world, is going to depend on your GPS quality. But let's say under ideal conditions, you're getting a clear view of the sky, you're getting good referencing from your base station that we use for processing, then that can be, kind of around the 3 to 5 centimeter range. So that's where it is. But intrinsically, within itself, if you're taking, measurements and doing the analysis that an engineer generally would, that's
Mhm.
when, yes, you're able to get kind of that one. So for example, a common application is a pole loading. So an engineer will capture a bunch of poles And then they want to know, all right, what's the height of attachment of all of the components on that pole? And what is this pole's position in relation to the next pole down the line for their tension analysis? And all the distance measurements that they are taking and extracting there have an accuracy of around a centimeter.
I saw your news about the pole recognition software ability. And so most of the time when you see this application like this, you see very, I would say glamorous, because it's really just site surveys, but their entire surveys, building sites or buildings in construction, not poles. So this is very specific, poles and utilities and cables. So I take it Looq has quite a bit of AI with object recognition in this software. Is that correct? Because I gotta say, everybody can take photographs, but it takes a little bit of human intelligence or AI. Hopefully, AI has stepped in here to recognize all those things as real objects. Am I correct in saying this is all AI based and you've got a good machine learning, or you've taught it well?
So, I mean, we're very excited about it. I think the level of glamour maybe depends on the work that you're doing. But I mean, that's always the approach that we've taken, right?
Okay.
We want to build things that are very useful for people in the specific workflows that they're doing. And that's really what the Q poll module is, right? It's taken something that people do. They walk around, they capture information about poles, then they kind of manually click on, all right, here's the base of the pole, here's the top of the pole, here are the two ends of the cross arms, here where all the attachment points are. And then they reference that to their, component libraries with all the details about the different types of insulators and conductors and whatnot. So it's a lot of manual clicking. And the traditional field capture techniques that they've used are kind of slow. So we're coming in and we're saying, all right, one, we're going to speed up your fielding. You can now get this information really quickly. And then that's on the field side. And then the back office side, you're having to click on the base and the top of a pole and the two ends of a cross arm. We have a ton of imagery, and it's very easy for us to identify that this is a pole and this is a cross arm in the imagery, and then pick the ends of that and project it into 3D, which is one of the advantages of being fully image based. We have that relationship between the raw images because they're used to derive the 3D point cloud. So any objects that you detect in imagery can easily be projected into 3D. It's a bit of an easier problem to solve than if you're working with LiDAR, for example, where you just have millions of points and you're trying to determine all the relationships based on geometry. Image segmentation is in general kind of easier to determine some of those things and then project it out into 3D. There, we're just trying to automate some of the things that, slow people down and free up, those expert resources and shift them more towards, quality control and the analysis portion, as opposed to kind of tedious clicking that has to be done, day in, day out.
Mm-hmm. Yeah, it's quite a bit of work this could help out with. So is the end result of this application that do you throw away the photogrammetry then and end up with completely like CAD data, the CAD models, or do you keep both sets of data?
We keep both sets of information. So,
Okay.
of course, it depends on the user. I think sometimes users are just doing their extraction and then moving on. You mentioned Autodesk. It's kind of a common survey workflow if you're making a topographic map, for example, to just reduce that point cloud down into a series of points and lines, extract, you bring all that information into Civil 3D, for example. What we're moving towards and what we're seeing more of now that people have had this technology for a little while, they're starting to see the longer term benefits of, when we have all of this information, and if a change is made, if somebody wants to attach something new to a pole, or if they, redo a portion of the road, for example, we have all of the existing data and most of the extraction is done. So you don't have to start from scratch. We have both the, high resolution point cloud data sets, and we have the models kind of saved in the back end. You can adjust a few things in the Looq platform, re-export, or, even kind of detect things automatically, via change detection techniques. So here's what's changed about this environment. Let's update it. And then we can update your model and help you get back to, the work that you do best.
How did you acquire the library of models to train on? Was it just a big project to go around? Like, I'm thinking of like a Google van, which all its cameras and it's going around all the streets. Or do you do something similar to that with utilities, with poles and other fixtures? Could be,
Yeah, it's a combination. There's some existing libraries out there that we're able to pull on for a set of objects, but it only gets you so far. And then for the polls, for example, there aren't a ton of existing libraries out there for some of the more detailed components, different types of insulators and whatnot on a pole. So it's a combination. We had a good starting point with some of the tech libraries that are out there, and then we were able to build on that, working with our users on what they liked, what they didn't like, what they needed to add. And it's a work in progress. We're still adding new stuff all the time, and we're going to be adding new stuff for the next couple of years. There's lots to do as we expand
right.
into new verticals and whatnot.
Yeah. Was there an existing market? Did you go up against software that the utilities themselves might be creating to do some of this?
For them, I
Okay.
we've definitely seen a large variation utility by utility in
Mhm.
terms of their capabilities. Some of them do have, very impressive libraries built out for detecting things.
Mhm.
But I think a common theme is that when it comes to the actual fielding and model generation, they often mandate, for example, an end software. You have to get it into one of these three loading analysis softwares, and they sub out the actual fielding and that process to their, engineering partners in general. So the engineering partners are often our customers, and we have integrations with the common loading analysis softwares. So we are able to help them kind of facilitate the transfer of information into the programs that they use already without having to go to them and force them to change their whole workflow, which, as I'm sure you're aware, going to a utility and trying to convince them to change off of, what they've been using for years and years, like from the fielding, from the technology standpoint, is hard enough, right? And then to go convince them to change into a different kind of final software is a whole other thing. So we're saying, hey, listen, we can help you get more information faster and in a more affordable way, and it'll feed into what you're doing now. It won't disrupt, your existing operations.
I'm up in the Northern California area. We have PG&E. That's our utility. What is it in Southern California? The
There's
utility
San Diego Gas and Electric, and then there's
gas that.
SoCal, Edison,
Okay.
the
Are
big
they all
ones.
customers? Or
And most of our customers are honestly their engineering service providers. So they
oh,
they are aware of us, and we do talk to them about things because they have standards. They want to make sure that the data that's being collected is done accurately and it supports their needs. So we've had discussions with them. But yeah, most of our customers are their service providers at this stage.
it seems like you've got a niche going. Might be, sounds like it could be a very big niche because there's a lot of utilities, and a lot of utilities have a lot of structures. What's next? Or was that even the original idea? I think that Luke was probably founded on more general surveying and photogrammetry, correct? Yeah.
Yeah, we definitely didn't dive into it saying
Uh,
like, all right, here we go.
yeah.
I mean, our founder, when he was doing his PhD, he was very focused on self-driving car technology. And then when we started the company, we saw an opening that we thought would make sense in the vertical, construction side of things. But I had been working with and around surveyors for a long time, doing mapping. And the more we talked to customers, we kind of saw the need there for, reliable and affordable and quick capture techniques. So our first customers were pretty much all land surveyors. And then the request came in, can you guys reconstruct a pole? Like, how do you perform on power lines? Like, those thin features are really hard to do. What can you automate there? And that's kind of how we ended up where we are today.
Was it, you mentioned the self-driving vehicles, which I'm fascinated by. Have you taken a ride in any of the robo taxis like the Waymos that are out here in San Francisco?
I actually have not.
Next time you're in the area, definitely do that.
I'll
But
have to give it a try.
yeah, so with the cameras initially, like what were they going to be like driving along with vehicles and recording the entire scene?
That was just his initial area of research. The first prototypes all came out on cars or robots, or that's kind of what he was doing for his PhD thesis, was kind of computer vision in that space.
Uh,
But then it was just, started the company through talking to customers. Hey, what are your actual needs here? What problems do you have? What is worth, paying for to you, that we ended up in the market that we are right now.
do you find the company has to be sort of on the defense again? Again, I'm going back to LiDAR versus photogrammetry, but is that a tough argument to make? To convince people that, hey, photogrammetry is usable and accurate? And do you come up against that a lot, or not? Not. I, I think once you show them models, they probably explain themselves. But do you get that chance?
I mean, I encountered it a lot at first when I was doing UAV LiDAR, you know, drone LiDAR back in 2018. People were kind of initially thrown off by the overall concept, but I think at the end of the day, it doesn't really matter to them. It's a quick discussion where they're like, whoa, like based on what I know about photogrammetry, it's not going to work. Take it, test it out, run it through its paces. I mean, what we know about the survey and engineering community is it doesn't really matter. You can say whatever you want, but at the end of the day, they need to test it out, right? And they need to validate it against what is known benchmarks. And so that's kind of the approach we've taken. Like, listen, don't take our word for it. Here's some data, play around with it. Take it out yourself, compare it to existing ground control and whatever LiDAR captures that you have, and I think you'll find that it stacks up extremely well and can get you what you need much quicker.
I think your founders, at least the founders, are probably aligned, if not friends, with Elon Musk, who always maintains that vision-based systems are sufficient. That's all we have as human beings, and we don't have radar or LiDAR, and yet we can make sense of the world. And he's insisted his vehicles have only vision-based systems. So I don't know if he's pro funding companies like Looq, but he's probably aligned with them, right? Because of vision-based systems. So, okay, so was my perception incorrect? It seems like you're bringing photogrammetry back, but it seems like photogrammetry had actually subsided a little bit. Is that just my impression? Do you find that not to be true? Or you're
I think at one point, I mean, you have to go back a little bit further, probably even before my time in the industry, really. Photogrammetry was all there was, right?
right, right.
You were making kind of stitching together large models, and you were coming up with digital surface models, which were just the tops of the trees and whatnot, which was still groundbreaking at the time. And then LiDAR kind of came on the scene, right? And all of a sudden you're able to do, from an aerial perspective, do large areas, even at a low density, a couple of points per square meter, but still get down to the base of vegetation, which was exciting, I think, from a large, when it came to more kind of granular, when you need really high density and resolution, topographic maps. The existing technology prevailed, right? GPS and total station. But drones came on to the scene, and all of a sudden, with LiDAR very specifically, you could do things like get the outline of a curb very accurately, but not as much from photogrammetry. You would need very, very high resolution images to get them from the air and spend a lot of time to get to that resolution. So then, LiDAR, I think when combined with imagery for mapping purposes, was very powerful, but LiDAR was kind of the standard in terms of the 3D accuracy. So I wouldn't say so much that it pushed photogrammetry to the side, but it was kind of the standard or the benchmark when you talked about, getting accurate, high resolution 3D information. And that's what we're coming here and saying, like, hey, listen, you can get that from photogrammetry. And as I said before, I still think that the technologies are complementary. I don't think that this is going to come in and just completely replace LiDAR in every sense. I think there's still a lot of great, uses and applications for it. But yeah, I think we're saying, like, maybe rethink what you know about what you can accomplish with photogrammetry, it can get the same level of accuracy.
To me, it always seemed as cost would be a big factor. I know it is with Elon that the real reason he uses LiDAR is that the camera is a lot cheaper than LiDAR, right? They're in the tens of dollars versus LiDAR, which is in the now dropped down to hundreds of dollars, hundreds, but it used to be thousands of dollars. I know that that's also a big factor in the in his thinking. Is that also Luke's thinking too? That is Luke selling photogrammetry technology based on its lower cost? How much is that camera, by the way? That Thor's Magic camera, how much is that?
We don't need the LiDAR, and we want to be just completely camera based that will help us fuel kind of our automation efforts on the back end. So that's the main logic. If we thought that LiDAR would significantly improve the performance of it, then we'd add a LiDAR system in. So that's kind of it. I mean, and then in terms of the pricing, we sell a subscription model, all in. You get camera, automated processing, unlimited users in our web application for around $30,000 a year.
A year, okay. Oh, so you don't buy the camera outright. It's you sort of rent it.
Yeah, so it's a bit of a change in logic, right? Because normally you'd pay a large upfront amount for a piece of hardware, and then you'd kind of assign a resource to process that data, right? And then you would do extraction off of that. So we're saying like, listen, we're handle everything. You get the camera. If something happens to it, we replace it. We have a very good return policy. So it is a piece of field equipment, so we're kind of standing behind the durability of it. And then you upload the data, it gets processed. You're not having to do anything there. And you just are able to kind of dive into your analysis much quicker.
So that fee, that 30,000 a year, is that like how can I say, am I limited to the number of projects or the amount of data that I can store? Or?
We do have a cap on it, but in general, it's quite large. And the amount that you would have to do for kind of a typical, let's say, surveyor engineer is far exceeds, what you would ever accomplish. So for all intents and purposes, it is an unlimited model for those types of projects.
It's like you haven't gone back and saying, stop eating all the shrimp off our seafood.
I mean, we do enterprise deals for people that want to use it 7 days a week, 10 hours a day. That kind of comes in more into the pull side of things, which of course is a bit of a different conversation. But in general, the usage is not that high for our engineering and survey customers.
Okay. Are you allowed to say, does a company say how many subscriptions it has, how many cameras are out there working?
Not exactly, but I mean, we've grown significantly in the past couple of years. I don't have it off the top of my head, but we've had just pretty explosive growth in the past year and a half. So it's kind of changing month over.
I'm really actually glad to see it happening because, like I said in the beginning, the technology photogrammetry just seems to be so immediately useful and accessible, right? That there's got to be some way, somebody's got to make this work. Just the process is cumbersome right now, but I love the fact that I could just use a digital camera to get 3D images. I guess I've been waiting for a company like you to come along to make this useful. So, yeah, good work. Keep it up.
You'll have to get your hands on one.
I'd love to see it in action, honestly. That's amazing. And, people have to realize that, cost is commercial grade products are worth it. That it's, you can't rely on, the idea that you could just pull a little digital camera or something out of your pocket and use it for industrial grade industry projects. I never put much faith in that, but people have to realize they have to pay for good equipment. Engineers need good tools. There's no way around that, right? So then they're not cheap. Yeah.
Yeah. I mean, engineers deserve great tools because they do a lot of hard work, and really nobody wants to waste time. Let's automate what is feasible and valuable to automate, and then let the engineers and surveyors focus on what it is they do best.
All right, very good. Thank you very much. Lucas, thanks for making the time available. I really appreciate it. Very nice talking to you.